morning everybody. Today we'll discuss about the concepts of ray optics. So this is the optics topic related to the light and its properties. So totally light has 6 properties. One, it is light is always allowed to path in straight line, allowed to path in straight line, and this law is called as Fermat principle. Fermat principle. According to the Fermat principle, the light is always allowed to path which takes less distance. For example, we have the 2 points A and B. So this is a path 1, path 2 is a path 3. So we know the path 1 takes less time. So it is nothing but the straight line. The light is always travel between 2 points along the path which takes least time, and it is called as a Fermat principle. Okay, and the second property it is interfere reflection. Third is refraction. Fourth, interference. Number 5, diffraction. And number 6 is a polarization. So the last 3 properties, interference, diffraction, polarization, it reveals the wave theory of the light. So first 2, reflection and diffraction, we can discuss based on the particle nature of the light and as well as the wave nature of the light. But last 3, interference, diffraction and polarization, must require the wave nature of the light. So today we'll discuss about the concept of the reflection of light. Generally, this reflection is a property of the any wave. So here we are discussing about the light. So when the light is incident on a surface, this is a medium 1, and incident on a reflected surface, and come back to the same medium, right? And the process is called as a reflection. So the light is incident on surface and come back to the same medium, and the process it is called as a reflection, and it is known as incident ray, is known as reflected ray, and the point is called as incident point, and the surface is called as incident surface, and the normal drawn to the incident surface, it is nothing but n. N is a normal drawn to the incident surface at the point of incidence. And here the angle between incident ray to the normal is known as angle of incidence, I, and normal to reflected ray, the angle is called as angle of reflection, R. And we have the loss of reflection. The loss of reflection, one, it is the angle of incidence is incident ray, reflected ray, plane of incidence, point of incidence is a normal drawn. The angle of incidence is equal to the angle of reflection is the first point. Second, the incident the incident ray, reflected ray, and normal drawn to the plane. These three are in the same plane. Incident ray, normal drawn to the plane, reflected ray are in the same plane. So same plane, it means the triple product of these vectors, it is equal 0. If you imagine the vector along the incident ray, reflected ray, and one more vector, and vector along the normal, then the triple product can be written as I cap r cap cross of n cap equal to 0, or r cap dot of I cap cross n cap, or n cap dot of I cross r equal to 0, because all are in the same plane. So the triple product of these vectors along the reflected ray, incident ray, and normal drawn to the plane, it is called as 0. So the light is incident on plane of incidence. Is actual path of the light ray, but when it is incident on plane of incidence, it deviates from the original path, and it is known as reflected ray. And here is incident ray, is the actual path of the light ray, is the actual path of the light ray. So the deviated path and the actual path of the light rays, the angle between them, it is called as angle of deviation. It's represented by delta. So angle of deviation can be defined as the angle between actual path of the light ray and reflected ray or deviated path. The angle between them, it is called as angle of deviation. So it is represented with one delta. So we know is a straight line. On the straight line total angle it is 180, but angle of incidence is equal to angle of reflection. So the deviation angle written as 180 minus of I plus r, but I plus I and r both are same. So angle of deviation 180 minus 2i, or angle of deviation which is 180 minus 2r. Okay, and we have some different cases also in the angle of deviation. So if the light ray incident normal to the surface, the normal drawn to the surface, along the normal only if light is incidence, means angle of incidence is 0. Angle of incidence always the angle taken between incident ray to the normal, but here the normal and the incident ray is grazing, so that angle of incidence is 0, and angle of reflection also going to be 0, and angle of deviation becomes 180 minus 2i, we know, which is 180 minus 2 into 0. So angle of deviation becomes, it is 180 degree for normal grazing. For normal grazing, the angle of deviation it is 180 degree. If the same light ray is grazing with the plane of incidence, so plane of incidence, normal angle of incidence is 90 degree, and angle of reflection also 90 degree. So incident ray and is reflected ray with plane of incidence, grazing with the plane of incidence. So angle of incidence is equal to reflection, which is 90 degree. Then angle of deviation, which is 180 minus 2i, 180 minus 2 into the value of angle of incidence is 90. So the deviation angle becomes 0. For grazing incidents, so grazing incidents, the angle of deviation it is 0. So two plane mirrors which are arranged perpendicular to each other, the two plane mirrors and arranged perpendicular to each other, the light incident on mirror 1 and reflected to incident on second mirror, and from here also reflection takes place, the final reflected ray. Consider the angle of incidence with the normal on plane mirror 1, it is theta. So this actual path, so deviation angle you will get from the first mirror, it is delta 1, mirror 1, delta 1, which is 180 minus 2 theta, and incident on second mirror. Here on second mirror we are calculating the angle of incidence. This is theta, and here it is, right, is actually original path. Here we are getting the delta 1, right, delta 1, this is 90, and the value it is 90 minus theta, because this is theta with the plane mirror is 90 minus theta, and become this is theta, and with normal on second mirror is 90 minus theta. Yes, it is also 90 minus theta. So is the original path for the mirror 2 is a deviated path, angle it is delta 2. So for the plane mirror 2, angle of deviation 180 minus 2 into angle of incidence is 90 minus theta, which is equals to 180 minus 180 plus 2 theta, so which is 2 theta is angle of deviation through the second mirror. So total deviation angle which is delta 1 plus delta 2, and the sign conventions also followed. So angle of deviation we can take clockwise and anti-clockwise also. We'll see in one of the numerical, there we'll know how to take the angle of deviation clockwise and anti-clockwise. Okay. If the same two plane mirrors are arranged with some inclined angle, inclined with the theta, the angle of inclination between these two plane mirrors, it is taken as theta, and the light ray is incident on first mirror, with angle of incidence is alpha, reflected onto the second mirror is a mirror 1, it is a mirror 2, and reflected from second mirror, and the reflected ray, if it is parallel to the first mirror, then we are calculating the overall angle of deviation. Is a normal drawn to the plane mirror 1, is a normal drawn to the plane mirror 2. Is the original path and deviated path, angle of deviation is delta 1. So angle of incidence is alpha, of course reflection also alpha. Then for the first mirror, deviation angle which is 180 minus 2 alpha, 180 minus 2 alpha, and for the second mirror, so what is the angle of incidence we are calculating here? Theta is an inclination angle between the mirrors, alpha is a normal alpha, this is 90 minus alpha, if it is taken as x, so total angle in the triangle it is 180. 180 equal to 90 minus alpha plus theta plus x. The value of x you will get it 90 minus theta minus alpha. And the normal, so total angle 90 with mirror. So subtracting x value. So angle of incidence on the second mirror you will get, it is theta minus alpha. 90 minus x, which is theta minus alpha. Now the deviation angle we are calculating on the second mirror, delta 2, which is 180 minus 2i dash, 180 minus 2 into theta minus alpha, right? And therefore the total deviation delta is equal to delta 1 plus delta 2. Delta 1 we got 180 minus 2 alpha. Delta 2, which is 180 minus 2 into theta minus alpha. This is the total deviation developed by these two plane mirrors. Okay. So here it is, one of the example numerical. Here is a plane mirror 1, plane mirror 2. So the light ray is incident on the plane mirror 1 at an angle of alpha, and which makes with normal, and get be deviated, reflected, incident on second mirror, and from this mirror also going to be reflected light ray second. Consider on the second mirror the angle of incidence, it is beta. So is original path and the deviated path, the angle it is known as deviation angle, and we are measuring the angle of deviation from the actual path to deviated path. So actual path to deviated path means this is the value of the delta 1, it is in the anti-clockwise. So this delta 1 written as 180 minus 2 alpha angle of incidence, and that should be in the anti-clockwise direction, and incident on second mirror, and from this mirror also going to be reflected, and this is the original path. Now from original path to deviated path, the angle it is delta 2, and we are measuring from the actual path to deviated path, and the delta 2 it is in the clockwise. So the delta 2 written as 180 minus angle of incidence at the second mirror, which is beta, so which is 2 beta, that to be in the clockwise. So overall angle of deviation written as delta 1 plus delta 2, and anti-clockwise angle, the angle it is taken as the positive we know, and the clockwise angle it is taken as the negative, right? So the overall deviation angle written as delta 1 plus delta 2, and delta 1 anti-clockwise, so positive 180 minus 2 alpha, and the delta 2 is a negative, so 180 minus 2 beta, right? So from this, if you simplified 180 minus 2 alpha and minus of minus plus, so the overall deviation you will get it 2 of beta minus alpha. I hope it is clear to you. Thank you.